Hey guys, it's Old Tennessee 34 again. It's been a while since I've been on YouTube. Been really busy working, covered up with jobs and whatnot. Wanted to show you a quick update on what I'm going to start. I may start a video. I don't know what you call it. I don't know. I don't know what you call it. Anyways, I may start a video thing on this. I'm gonna build a steady rest. The one I have, let me show you what I have. The one I have is over here. I've got a mess in here. I'm trying to clean up and get this going because the one I have is this. It's just one that came with the machine. It's not very good. It's not a very good steady rest. Came with a follow rest too, and it's not the best either. Anyways, as you can see, this thing doesn't give you much room to open up here, and I'm needing to hold. I'm boring this pipe. You see here, leaving a pretty decent finish, but you start getting a little bit of chatter. I did buy a bigger chuck for the lathe. I'll show you what I got. Let me get this open. I bought an 8-inch 3-jaw that has the removable top jaws. You can bore these soft jaws to fit whatever parts you're working on. Works really well. It just uses a tongue and groove system. It works real good. This chuck is doing a good job for turning the pipes, but I need a bigger steady rest, so I'm going to start off with a base here, and then we're going to put this riser. We'll make the riser out of some thick material like this. We'll have a bolt back here. The riser will come up on an angle. We're going to do an angle on the riser with a 1/4-inch radius spacer that's going to hold this chunk here. Of course, I'll turn this down. It'll sit like this. Like so, I'm going to put a 1/4-inch wedge. It'll be a 1/4-inch high, but then it'll come up on the radius of this. And then once everything is here and welded where I want it, I'm going to put it on the lathe and put me a center drill or a spot drill or something on there and just slide this toward the chuck until it touches. Get me a center mark, and then I'll drill this out on the mill and get it close. I'd like to be able to on my steady rest, do at least 2 3/4 diameter. So we'll do something like this. The ends right here will have bearings on them. So we'll have I don't have to decide what size bearings I'm going to use yet, but I would like to use the bearing on the end of my steady rest. I've got some little, I don't think these would be very good. I don't think that withstand a lot of load. Something dirty in there. Okay. But I would like to do some bearings of some sort. I don't think I have any I can show you, but I would like to have something like this and have a bearing on the end. So I'm gonna work on that. We'll do a dovetail with some maybe a screw like this and some bearings on the end. Have some small bearings, but I don't know if they'll work or not. Anyways, that's the project I want to start. I've got to get this built. I'm not necessarily going to cut nothing out here because it doesn't matter. I'll have my bolt hole on this side. And that should be sufficient. If not, we'll cut some material out. Put it out here. But once we get our round on, we get us a mark. We'll go from there. I could bore this out. I could bore this out to 2 3/4, and then maybe put a piece of metal in here and or turn it to 2 3/4, slide it on there, and then fit it on here. Maybe even tack weld it on here while it's in the chuck, and tack weld it. Then when I take it off, I can do a full weld. But you still may run into some issues with that. I don't know. We'll see, because I don't want the weld to pull the circle off center. We'll see how this works out. We may end up tack welding on there, and then get everything where we want it, and maybe bolt it down and then bore. I don't know. We'll see. But that's, like I said, if you got a comment on what you think I should do with this, let me know, because like I said, I'm trying to figure, how am I gonna, I've got to make sure that I get a good, it don't have to be perfectly centered with the chuck, because you're gonna have your adjustments. But this one's, that's pretty close, I guess. So we'll see how, I don't know. Put in the comments what you would do. Let's see, I don't think I've done anything new to the lathe since I've been last on. It's been a while since I've been on. I did, I've learned more on the ELS4. There's a learning curve. You gotta learn how to program that dude. But also thinking about going to a 40 position multi-fix type tool holder. Been looking at those, don't know much about them, haven't really done a lot of research. I've seen them a couple times, been looking. If you have one, or know somebody has one, let me know what they think of it on these smaller lathes. I'd like to know what people's experiences are with them before I spend some money on doing such. Well, I think that's it. I just wanted to give you an update. I'm gonna try to do more videos. I've just been so busy working. It's been I don't know how people do it on YouTube all the time, but I'm gonna try to do better. Oh, I did add coolant to this system, so it does have, I'll show you real quick. It does have in the settings, if you go to outputs, where you at? Outputs, and you can set up coolant output. I've got to turn to yes. So what happens with this is, this thing actually, it has a delay. You can delay so many seconds before the coolant turns on. So this sends a signal to, and this, I've still got it roughed in. I haven't had a chance to finish it up yet. This sends a signal to a relay, 12-volt relay. And the 12-volt relay, when it sees the signal, makes the contact between the power source, 12-volt power source, and the pump, which is right here. And like I said, I've just roughed this in, just got it done today. It will take coolant from here, pump it through the system. It goes through this white line, comes up to the coolant. I've got two different attachments. You can attach the coolant here if you're drilling with this thing, and you can set your coolant up to where it just washes the drill off. Or you can take a 1/8 inch Allen wrench, and you just unscrew this a little bit, and unscrew this a little bit, and it'll come off, and you can actually attach this. Let me see if I can get it on here to show you. You can attach this to the tool post. All right, get it in there like this. It's almost on that, sort of raised up on one side. There we go. So you just snug it up. You don't have to really gut wrench it here, but you tighten these two screws up. So if you're doing a turning operation, for say you got your turning tool in here. You can take your coolant and have it right on the tool, like that. Or like I said, you can put it up here. If you're drilling, if you're doing just a drilling operation with your tool post drill, it will just, I don't have a drill over here. So if you have it in there and you've got the coolant tip up here, as the drill's drilling, the coolant will just be right there on the drill, washing the end of it off as it goes in and out. Works really good. And the coolant, it'll turn it on and off automatically. So when the cycle's done, it turns it off. I've got it to where it stops the chuck now, so everything turns. The cycle's done, it just stops. Turns the chuck off, turns the coolant off. I've got a coolant. This was a mist system originally, but I've got control with flow right here. So what happens is when the pump comes on, the pump will pump full pressure basically into this line, because there's going to be a second line coming off and dumping any excess pressure back into the tank. So you can adjust your flow up there, and it comes through the drain. I've got a hose for this. Don't have it on yet, and the hose will go right back into so it drains into the pan. And like I said, I've just got everything. I've still got my panels and stuff off, but so far it's working really well. I'll give you an update. Next time I'll have everything buttoned up. I'll have my hoses on, and I'll have my bypasses and stuff fixed up to where we can see it running. I did add a ball screw to the X-axis. Took a lot of modifications. I'll show you. Let me turn the Z off, and I'll show you the ball screw. So I did put the ball screw in, and it's attached to the stepper. And this thing has like almost no backlash. So we'll zero our X right here. And I'm gonna move it, let's say 15 thousandths that way. I'm gonna go the other direction. That's gonna be hard to show you that, but I'll show you. So if we move this, right there's where we're at. If I move it one line, it moved at about 4/10, and I'm gonna move it another line. It's moved at 1,000. So it's moving almost immediately when I go the other direction. So I'll go back to 0. I'll start going back the other way. So we're 0, let's say we're 0 here. If I can get this thing to go to 0 or not. No, I can't. Let me try here. We'll come back this way. That way we can go to 0. There's 0. And we'll 0 this. And we'll sort of see what happens here. So we're going to go see how far off from the dial from our backlash. So let's go to 0. Make sure I'm going the right direction here. Make sure I'm going the right direction before I start making any measurements. All right, then let's 0 this. Now let's keep on going the same direction. This dial says that we're going to go right here. It's 20 thousandths. And we've moved 15 simply because this pitch is different from what they set this dial to. But if you look at the measurement on here, so if we turn our X off and the X is on, we 0 this. Let's put this in metric so you can see. We'll put it in metric. And I'm gonna tell this to move. 0.19 it moved. That's how much it actually moved. 0.31, That's how much it actually moved. So the control thinks it's moving. I say it thinks it's moving the x-axis 2.2 millimeters. And it's following on the DRO. So it's a pretty, this dial is not accurate because I've changed the pitch, but so far I've had pretty good luck out of this whole system. So like I said, I'll give you an update on the coolant system when I come back. So far it's been working good, and appreciate you watching. Comment down below what you think I should do with this steady rest. I've got to get this done so I can start the job. I got to quote the job, then I'm gonna try to get the job so I can do it. But comment below what you think I should do, and we'll see what we can do with it. Thanks, guys.